Do you remember a long time ago when we started talking about permutations? And in permutations, we said the best example is a combination lock. And it shouldn't even be called a combination lock. It should be called a permutation lock. Think of the numbers in your lock that would work. Let's just say 12, 21, and 36, let's say, are the three numbers that will open up that lock. That order matters. So if you think about it, if we used 21 and then 12 and 36, the cool thing is that's a completely different set of numbers that could open up a completely different lock. So the order matters. Even if I put 36 first and then went 12, 21, that will not open up your locker lock, will it? No. The only combination, or I should say permutation, that'll open up the lock is that one. So every one of these is different. So the order does in fact matter here. Well, let me show you what a combination is all about. Combination says order does not matter. Well, what would be a great example of that? My favorite? Coffee. Of course. I love coffee. But think about the people who have coffee. Some would like cream and sugar with their coffee. So let's say cream, let's call it CR, sugar, and coffee. Got a question for you. That'll make the perfect cup of coffee for somebody. But I got a question for you. Okay? Can you put sugar and then cream and then your coffee? Well, yeah, that'll give you the same thing. Well, how about coffee first? Can you put coffee first and then sugar and then cream? Well, yeah, that'll work too. How about coffee first, then cream, then sugar? All of those make the same cup of coffee, doesn't it? Order doesn't matter. That's a combination. Ah, now you see it, right? Okay. So how does this work? When you're talking about a combination then, it says of n objects, n different objects take an r at a time. What do you mean by that? Okay, real simple. You're going to have n total number of objects. You're going to pick r of them, and in that, the order doesn't matter. And I'll get to a lot of examples right away where you'll see the order doesn't matter. The key thing here is the notation. You can use the C notation just like we had before. We had the P notation. We said NPR for perms. Well, guess what? Now we got NCR for combinations. But there's also a different way of writing this. It's actually N over R. Now, how do you remember if this is combination or permutation? Because this bracket kind of looks like the C, doesn't it? Aha. That's what's going to make it nice and simple. But here's the cool thing. Look at the formula. The formula says it's a perm divided by the number of arrangements, divided by r factorial. Why? Because that's going to get rid of all of those duplicates, right? Think of the coffee one, where you got a cream, a sugar, it still makes coffee. A sugar cream goes with a coffee, or coffee first, then sugar and the cream. It still makes the same cup of coffee. So by dividing this by r factorial, the number of arrangements that we have, that's going to get rid of that wonderful duplicates that we have, okay? So keep looking at the formula. If you play around with the formula, eventually you're going to get the actual formula that's on your formula sheet. That's this one here. Right? And you can take a look at this formula all you want and play around with it, and you can see all the algebra that goes along with it. But the important thing is it's there. Now, cool thing about this, let me show you something. Boom! We can start doing questions right away. Think how this is different than a permutation. Okay? Look at this question. It says 3 students from a class of 10 are to be selected to go on a trip. Well, what if those 3 students were, oh, I don't know, Jennifer, Bill, and Bob? Does it matter if Bill's chosen first and then Jennifer and Bob? No, all 3 are still going. How about if Jennifer's chosen first, then Bill and Bob? No, all 3 of them are going. You don't care about the order. So this is what makes it a combination. So same as before. Look, you have 10 students to choose from, okay? 10 students, you're going to choose 3. Notice how I didn't say pick. I'm actually saying choose 3 now. Because if it was pick, then it would be a perm and the order would matter. It would be like saying Jennifer's picked first, she has to go in the front seat. Then Bill's picked second, he has to go in the second seat. And then Bob is picked third, he's got to go in the third seat. Whereas you just say, oh, get on the bus, both, all three, Jennifer, Bill, and Bob. Who cares the order? So the order, you don't care, it's a combo. Now, you could also write this as 10, choose 3. Either way, that's fine. But let's go back to the formula then. The formula, if you remember, looks something like this. This is 10, choose 3. According to the formula sheet, is 10 factorial over 10 minus 3. Okay, that's also going to be factorial, and 3 factorial. Oh my gotcha. What a mess, hey? But all you got to do is throw that into your calculator, and you'll get a beautiful number of 120. All right, how can we do this on our calculator now and make it real simple? I got my calculator sitting here, and just like before, you're going to go into that math program. You can zip over here to the probability, and sure enough, there it is. So you can pick number 3, and it'll pop up, and you have to just put your 10, and mouse it over, and put your 3, hit enter, and you get the exact 120 again. But is there a way of doing this with the alpha buttons? Well, of course there is. Just like before, you'll hit alpha and F2, and sure enough, all the way down here at 8. See, there's your perms, there's your coms, there's your factorial. It's all there. So just hit the 8 now, boom, and shows up exactly the same. All you have to do is now fill in the digits, hit enter, and away you go, and you got your 120. Now, let's take a look at a great question here. I love this because one of these days I'm hoping I can win this, right? A Lotto Max. Now, my question is this. When you choose those 7 numbers, does the order matter? Think about it. If your numbers are, let's say, 7, 9, 12, and whatever, okay? Does it matter if you choose 9 first and then 12? No, you got the numbers. That's all that matters. The order does not matter in that. So this becomes a combination. So you're choosing 7 numbers from 1 to 49. So in fact, you have 49 numbers to choose from. You're choosing 7. I can't wait to see what this is going to work out to be. Look at this. This is 49 factorial. So that'd be 49 times 48 times 40, 47 times 46, all the way down to just, oh my goodness, that's going to be huge. And then because you want to get rid of all of those crazy combinations, right, all the duplicates, you're going to go 49 minus 7 factorial, and then divided by 7 factorial again. Or you can write this as 49 choose 7, or better yet, you know what, let's just throw this into the calculator right now. Okay, alpha 2, there it is. I want to pick 8. I'm going to go 49, and I'm going to choose 7 numbers. The order doesn't matter. Look at your chances of winning the Lotto Max. Ready? Yeah, sure. Okay, you have a 1 in 85,900,584 chance of winning the Lotto Max. You know what I say to that? Stay in school.